everybody. Hope you're ready to flex those brain muscles, because today we're going to talk about synthetic division. And what synthetic division is, it's another way to divide polynomials, and a lot of times it's a shortcut. It's a faster method than doing the long division of polynomials. So there are some requirements. There's some conditions that have to be met in order to be able to do synthetic division, and there's two of them. The first one, this denominator, right, the divisor, the thing we're dividing by, the highest degree, it can only be a first degree at most. So we can't have any x squareds, x cubes, none of that. So usually what you'll see is a binomial like this, and that's the giveaway that, okay, I can use synthetic division. You'll see like x plus something, x minus something, and that's when you can use synthetic division. And the second requirement is that the leading coefficient here has to be 1. And if it's not 1, there are ways you can modify it. Like if it's 2, you can multiply by 1/2 over 1/2 and get this to be 1. But for the most part, the examples you're going to see are going to be a polynomial up top, and then there'll be a binomial on the bottom, x minus something, x plus something, something like that. So since this expression fits those two conditions, we're going to go ahead and practice synthetic division. So the first thing we do is we set the denominator equal to 0, and we solve for x, and that's the number we're going to use. So x plus 1, we're going to basically find the 0 of x plus 1, and that equals -1. So where our -1 goes is right here. This is how we set up our synthetic division. I write my -1 here, and I draw like a really long L, like this. And what I put here are the coefficients of each of these terms. So another thing you need to make sure is that these are in order from highest degree to lowest degree, right? And in this case they are, so I'm good to go. And I'm just going to literally list the coefficients in order from highest to lowest. So I have 1, because there's an invisible 1 out here. And then I have 2, I have -3, and I have 1. And again, if there's any term missing, if this was missing the x squared, I would fill it in with 0. You always need to make sure you do that. So how this process starts, the first step is this 1 gets brought down to the bottom. The 1 comes down. Then I multiply. -1 times 1, that is -1. And I put that number here. And then I add down. 2 plus a -1, in other words, 2 minus 1. I have 1 here, and I do the same process, and I just repeat it. -1 times 1, that is -1. Then I add down, that gives me -4. Same process, -1 times -4, that's 4. Then I add down, 4. Then I add down, and I get 5. So what do these numbers mean? Because this is kind of a shorthand for how we divide. What do these numbers mean? Well, this last column is always our remainder. I'll just abbreviate it, REM, remainder. This last column, always the remainder. So in this case, we have a remainder of 5. This is our constant column. This is our x column. This is our x squared, and it continues in that order for however many columns you have. So this is going to be just a -4, because this is just our constant, or you could think of it as the 0 degree power. X to the 0 is 1 times -4, however you want to think of it. So this is the constant. This is the x column, so that's just x. And this is the x squared column, so that's just x squared. So what am I left with? After doing this division, I'm left with x squared plus x minus 4 with the remainder of 5. And again, how do I express my remainder? I write it as 5 over x plus 1. I always write it over the divisor. So plus 5 over x plus 1 and that is how you do synthetic division to divide polynomials. All right, next example. At this point, I encourage you to pause the video, try this on your own, and then unpause it whenever you either get stuck or if you get the answer, if you want to check your answer. So this example, we'll go ahead and start. What's the first thing we do? We set the denominator equal to 0, and we find the zeros of this denominator. X minus 3 equals 0. I solve for x, and I'm left with x equals 3. I just added 3 to both sides. So x equals 3, that's what goes here. The 3 goes here, and it's outside my really fat L. Okay, and what goes in here? The leading coefficients, but I have to make sure these are arranged from highest to lowest degree, and in this case they are. So I have 1, I have -4, but look, be real careful. I'm missing an x term. It jumps from second degree to 0 degree, right? I'm missing an x, so I have to fill it in. 0, and that's -5. Let's start the process. The 1 comes down, I multiply, 3 times 1, that's 3, and then I add down, that's -1. 3 times -1, that's -3, then I add down, that's -3. 3 times -3, that's -9, and then I add down, that's -14, which is my remainder, right? This is remainder column. This is our constant, this is our x, this is our x squared. So what are we left with? X squared, and that's just 1x squared, minus 1x minus 3, with the remainder of -14. So how do I express this remainder? I express it as a fraction over this divisor. So since it's a negative, it's going to be minus 14 over x minus 3. Okay, for this example, we're going to show that x plus 1 is a factor of this polynomial. And this is probably the most common application of synthetic division, is to show that some binomial is a factor of some larger polynomial. And we do this if we need to graph these large polynomials, or if we need to fully factor them. That's when we use this method. So what does it mean for this to be a factor of this? Let's think of what factor means. So what are the factors of 4? We have 4 and 1. We have 2 and 2. So what does this mean? If we divide 4 by 4, we get 1. If we divide 4 by 2, we get 2. If we divide 4 by any of its factors, we get a whole number. And another way to think of it is we have a remainder of 0. And that's exactly the idea we're going to use behind this. Because think of 5. What are the factors of 5? Just 5 and 1, right? 5 divided by 5 is 1. 5 divided by 1 is 5. But what if you divide 5 by 2, which is not a factor of 5? You get a remainder, right? You get 5 over 2, which can also be written as 2 remainder of 1. So you get a remainder. So if I divide this polynomial by this, and the remainder is 0, then x plus 1 is a factor of this. If the remainder is not 0, then x plus 1 is not a factor of this. So let's go ahead and try it. All right, so we're going to go ahead and divide by x plus 1, because that's exactly what we're doing. So what's our first step with synthetic division? Well, we write this and we set it equal to 0, right? We're finding the zeros of the denominator. And if I subtract 1 from both sides, I get x equals -1. So what do I do with that -1? Well, it goes outside my big L, right? And what goes in here? Just the leading coefficients. And in this case, I have every term I need. I have x cubed, x squared, x, and the constant. So I don't need to fill anything in. I could just write everything out. So 1, -4, 1, and 6. And now I can bring down this 1 and I start the process. -1 times 1 is -1. -4 plus -1 is -5. -1 times -5 is 5. 1 plus 5 is 6. -1 times 6 is -6. Oh, look what happens here. 6 plus -6 is 0. This is my remainder column, right? I have a remainder of 0, which means that x plus 1 is a factor of this polynomial. So, like I said, this is a very common application for synthetic division. If you enjoyed the video, make sure to hit like. If you have questions, you can comment below. Also, make sure to subscribe and keep making those brain gains. Keep flexing those brain muscles, and I'll see you in the next video. Thanks.